Okay, so guys, this is the phase three of the PubSub prod application that we are building. And in this phase, we have implemented the PubSub application in a distributed manner. Because like if we are implementing it with a central server, there are some issues that we cannot handle. For example, we cannot scale it up and there's too much load on a single server. So uh, this is the system model of the PubSub distributed system. And as you can see that we have used Docker to implement this. And this client here, client one, client two, server and publisher two, server two, all these are in separate containers. And these containers are connected with a custom bridge network. So to understand what's actually going on here, let's take an example. So for example, uh, suppose there are five topics: weather, politics, sports, UB, and CSC 586. So suppose publisher 1 decides to publish topics related to weather, politics, and sports, and publisher 2 decided to publish topics related to UB and CSC 586. These publishers would let the servers know which topics they want to publish. So for example, Pub1 uses server 1 and Pub2 uses server 2. So now server 1 will handle topics related to weather, politics, and sports, while on the other hand, server 2 will handle topics related to UB and CSC 586. Now, each client makes a connection with any server. So for example, client 1 establishes a connection with server 1, then server 1 will assign client 1 with a random list of topics which the client will be subscribed to. So suppose client 1 has been assigned topic sports and UB as subscriptions. Now, as I've mentioned earlier, sports is handled by server 1, but UB is handled by server 2. So how will they communicate? Here comes the distributed nature of the application. The server 1 will now inform server 2 that one of the clients that is connected to server 1 needs information about the topic which is handled by server 2. And then server 2, after knowing that, sends that information to server 1, which then delivers the information back to client 1. In this way, the resource is shared among the different servers, and no particular server needs to bear the load of the entire data. At the same time, all the clients are getting news about different topics. And this is the interaction sequence diagram. As you can see that first the servers are set up, the publishers publish their topic, and then the clients get connected to the servers and they're notified of the different events. So now let's look at the program running. So if I give this command docker compose up, okay, so as you can see, the servers are getting started. Okay, so now, so the servers have started, and here client 1, its subscriptions are sports. Now sports is handled by server 1, okay, and client 2 subscriptions are politics and UB. Okay, so politics is handled by server 1. Okay, so but client 2 needs that information, and it would get information about politics from server 1 actually. And as you can see here, So if you see here, received from Master Politics who will win Democratic Republic. So server 2 is actually getting information about um, politics, although politics is getting handled by server 1. So as you can see, server 1 is telling server 2 that its subscriptions are UB and CSE586. So that means server 1 is handling topics related to politics. And although server 2 is connected to, although client 2 is connected to server 2, it still got information about politics, which means that there is a communication between the servers. And in this way, the system is distributed. So if I now stop it, as you can see, all the processes are getting stopped. Okay. And the last server. Okay. So that's it. Thank you.